Okay, so today we'll be discussing shift registers. And before we start off, we need to know what registers are in the first place. Now, registers are basically devices that store information, and it does so on the basis of flip-flops, where every single flip-flop stores one bit of information. These here are the types of flip-flops: D, D, JK, SR. Now, this entire thing is one shift right register. And within this, there are four flip-flops, one, two, three, four, all of the D type. And the reason for that is every single flip-flop can store one bit of information. So for 4 bits, like in this case, we need four different flip-flops, each storing one bit of information. Now, we start off with a shift left register. This is entirely a shift left register, sorry. Now, with the shift left register, this is what happens where the values, for example, start off with 0000. The first value to change is A, and then B, and then C, and then D. Every value shifting one to the left. C. The one from here goes here. The one from the input goes here. The one from here goes here. The one from the input goes here. The one from one here goes here. I'll explain this better here. As you can see, the one from the input goes to A. The 0 from A goes to B. And since the rest is 0, it doesn't matter. That's what happens. The next time I click this one goes into A, this one goes into B, the 0 goes into C. So it becomes 1, 1, 0, 0. I do it again. This goes here, this goes here, this goes here, and the 0 goes here. I do it again, and this happens. Now, after 4 shift pulses, the entire data went from 0, 0, 0, 0 to 1, 1, 1, 1. And since all of it has been set as 1, me clicking this won't do anything. And that's what happened. From the input to A, from A to B, from B to C, from C to D. From the input, assuming the input is somewhere here, it went to A. From the input to A again, and from A to B. From the input to A again, from A to B, from B to C, as we can see here. That's what happens. The next time, now, let's assume that the inputs we start off with are 1, 1, 1, 1. That is this. Now, the reason I changed this from 1 to 0 is I want to show you what happens when you use alternating inputs. Now, with alternating inputs, the second I use 0, what happens is when I click this shift pulse, the 0 will go to A. The one from A will go to B, the one from B will go to C, the one from C will go to D, and the final one, which is here, going out from D, this will be simply transferred out. And by transferred out, I mean, if you assume that this is entirely a small part of a bigger process, and that this shift register, this shift left register, is transferring this data to a next part, a different component of the computer, then that is done through this bit. Now, the second I press 0, the second I press shift pulse, the 0 goes to A and it becomes 0, 1, 1, 1. Now I use 1. What happens now is the new pattern turns into 1 goes to 0, 0 goes to 1, 1, 1. So 1, 0, 1, 1. I use 0 again. The new pattern becomes 0, 1, 0, 1. This 0 goes here, this 1 goes here, this 0 goes here, this 1 goes here. So the new pattern becomes 0, 1, 0, 1. And the final one gets transferred out. The next time I use 1, it becomes 1, 0, 1, 0. That's what we can see here. Because what happens was the 0 from the input went to A, the one from A went to B, the one from B went to C to D. The next time I use 1, the 1 went to A, the 0 from A went to B. We can see that here. The next time I use 0, the 0 went to A, the 1 went to B, the 0 went to C. So 0, 1, 0, 1. The next time I use 1. So the 1 went to A, the 0 from A went to B, The one from B went to C, 0 from C went to D, and the one from D just left, like we see here. It exited. This was a shift left register. Now I'll show you a shift right register, which basically works exact same way. The only difference is that it shifts the values to the right. So to show that, I'll just simply change the labels. What was once ABCD is now DCBA. DCBA. Okay, now this is a shift right register. Now with the shift left register, what we saw is the values were shifted to the left. The one went from A to B, from B to C, from C to D. With the shift right register, they work the opposite way. The values go from D to A instead of A to D. So it goes from D to C, from C to B, from B to A. So the first one that should change here is D. That's what happens. The next one that should change is C, because the one from input goes to D, the one from the D goes to C, and the 0 from the C goes to B. Like here, from the input to D, from the D to C, from C to B, from B to A. We do this 4 times, that's how it works. So it's literally the exact same application, except for the shift left register. It was from the right to left. Sorry, yes, from right to left, like here. Everyone moved to the left, and here it moves to the right. Now, let's assume that our starting value is this, 1101. Now, the task I have is to maintain this value, to transfer this 1101 to the next component, like I told you before. How do we do that? We don't set any more values, we maintain them using 0. So what will happen here is 0 will go to D, the value from D will be shifted 1 to the right to C, the value from C will be shifted 1 to the right to B, the value from B will be shifted 1 to the right to A, and the value from A will be shifted to the right and out of the system, out of the register. So 1101 will become 0110 because this one gets shifted out. And then again shifted to the right, 0 gets transferred out. Shifted to the right, 1 gets transferred out. Shifted to the right, 1 gets transferred out. Shifted to the right, the entire value disappears. What happens here is, this is what we can see. This was our initial value. Our task was to use this value and transfer it to another component. So what we did was shift the values 1 to the right, 1 by 1. We shifted this entirely to 1 to the right. So the 1 from here disappeared to the next component, and these two ones moved 1 to the right to here. Now this 0 shifted, the 1 came here, the 1 came here. This one got shifted, the 1 came here. This one got shifted, 0 came here. So what happened was, the value we started off with 1101 slowly got transferred out, and what we were left with was 0000, an empty register, because the 1101 was shifted out 1 by 1, as we saw here. And that's how a shift right register works, which is exactly the same as a shift left one. So basically, for example, we need to set a value 1, and now I want to transfer this out. So what I'll do is click it once, twice. Sorry. This is the value that I need to transfer out, 1. I set it once, the value has been set now. The reason I change it back to 0 is I need to maintain this value, but I also want to transfer it out. So what will happen is, you shift 1 to the right here, then here, then here, until it leaves here, 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 leaves. And that's how this works. The shift right simply goes from D to A, shifting the value to right, and the shift left was from A to D, going 1 to the left. 1, 2, 3, 4, like this. And the main purpose of this and these shift registers are to store the data using store the binary data by shifting them one to the left or to the right based on which type of register you use. Okay, so another thing that you can do with shift registers, shift left and shift right, is you can add and remove as many flip-flops that you as many flip-flops as you want. And obviously that determines the size of the data that you can store or change. So for example, I'm not happy with 4 registers. I want something to carry, let's say 5 registers. Then I can do that too. If I simply copy this, move this here, and simply repeat the steps that I've done before, where the output of this becomes the input of this, and this also gets the clock cycle, that is the shift pulse, and finally this gets its own output. And now what I've simply done here is this now becomes a 5 flip-flop register, and it works just as well. As we can see here, if I do this, it works just fine. If I do this, works just fine. For example, I name this, let's say E. It will work just as fine. And that's just the addition bit. We can also remove these flip-flops for as many as we need. Let's say we don't want this, we can remove it. We don't want this, we can remove it. We only want to work with 3, we can do that too. All we have to do is simply restrict it to where we want it to be. As it's not limited to 4, it can be it can basically contain as many flip-flops as you want it to based on as much data you want it to contain. And as I've removed that entire bit, it'll work just as fine once again. Same functionality as before. The only difference is instead of the 4th bit being the one that transfers the data, it is now going through the 3rd bit. It works just as fine. And that's another application that can work for both the shift right register and the shift left register. We now move on to shift around registers. Now, as we saw in shift left and shift right, once we transferred the data out of the register, we couldn't retrieve it. And that's what a shift around register is for. What basically happens here is any data that does get transferred out comes back into the register from the other end. So basically it shifts around the register. And we can see that here, where let's assume this is the output that we want to shift around. As you can see, it started off from here, slowly got shifted to the right. That is, this 0 came here, 1 came here, 1 came here. But this one transferred all the way around to here. Shifted it again. The 0 transferred all around the way to here. Transferred again. This one transferred all the way around to here. We did this until we got the original statement back. And that's how this works. And we can see that by testing it here. It's 1101 for DCBA. Let's assume this is D. This is C. This is B. And this is A. And what will happen now is if we input this 1101 into this 1101, sorry, 1101. Now, this shows that the current output is 1, which means 1 is the value that should get transferred back to here. So if we assume that this gets shifted 1 to the right based on what we saw in shift right, the new value should become this goes here, this goes here, this goes here. So as this 1 disappears, it should become 0110, right? But no, because in that case, there was no value left here. So what came here was 0. In this case, the new value here will be the one that is here. So we do it, and it's 1110. This value came here. Now, what happened is the 0 will come here. You can see that. And now what will happen is this 1 will come here. And finally, for one last time, after 4 shift pulses, we get 1101 as we saw here. And that's basically how this works. It simply shifts the value around. So it's kind of like maintaining the value, or for example, you don't need to shift the value out of the register. You just need to maintain the value. That's what this is basically used for. And it works on the same principles, except for this time, instead of D flip-flops, we can show the working through JK flip-flops, where the output of this goes as the input of this, same as in the D flip-flop, where the output of one went as the input of the second. Here, the output of this becomes the input of this. The output of this becomes the input of this. And that's what happens. And finally, the output of this becomes the input of the first one, which is why it was always shifting around. Now, that was the shift around register. Now we'll move on to the bi-directional shift register. And basically, this is how it works. Now, from bi-directional, we can assume a simple definition that it works in both ways. That is, it can shift left and shift right. Now, if we assume dr to be, or let's label it shift right for your understanding. If we label this shift right, and we label this shift left, then this is what we can see. If it's currently on shift right, if it's currently on shift right, and we select mode 1 means shift right. If we do this, now what happened is we chose mode 1, meaning it's going to work on shift right, and since it's working on shift right, and we're shifting the value 1 to the right, what's going to happen is 1 should come here. Yes. The next time I click this, what should happen? 1 should be shifted right over here. Yes. I do this again. Yes. I do this again. Yes. If I want to shift the value 0 to the right, that's what happens. I want to shift this value 0 to the right again. That's what happens. I'll zoom it in here so you can see it more clearly. I want to shift the value 0 to the right again. I do that. And again. So basically this and this input decides what value you want to shift right or left. And here 1 or 0 decides if you want to work with shift right or shift left. Now I'll prove this by showing you that currently it's on 1, which is shift right. The reason I say that is because no matter what I do here, nothing gets affected here. If I click this one, it's gonna simply work as shift right, not shift left. See, every value gets shifted 1 to the right. I change this, it works as a shift right again, except this time it's shifting 0 to the right. Here, here, and now here, and now here. And if I make this 0, you may think that maybe the value should remain 0, but no, only shift right works for this. It becomes 1, 1, 1, 1. And that's why the mode select is important. Now, let's assume that I don't want to shift the values to the right. I want to shift them to the left. So what we simply do is we flip the mode select to 0. Now it works as a shift left. And now let's assume I want to shift the value 1 to the left. So now it's going to work from here to here to here, shifting left. 1, 2, 3, 4. And now if I want to shift the value 0 to the left, it's going to work from here again, from 0, 0, 0, 0. That's exactly what happens. And that's basically how a bi-directional shift register works, where the mode select decides what value you want to shift. Oh, sorry, the mode select decides what kind of a shift register it works as. And in this case, 1 works as a shift right register and 0 works as a shift left register. Whereas the value over here, that is 0 or 1 or 0 or 1, this works as the value that you want to shift to the right or the left. And being bidirectional, this register can work as both. And this is, instead of making a shift right and a shift left register, you can simply use this one. And it has the same basic functionality. For example, the functionality that we discussed in shift right register or shift left, assuming we're doing it with shift right, that this is the value that I want to shift out. One. Now it's going to simply move here and here and here until it's shifted out. And soon it gets shifted out. And I can do the same for the shift left. For example, I want to shift this value here. And I want to shift this value out. It's going to go here, 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 then out. So it's basically the exact same thing, except it works as a two-in-one, which makes it an easier application. Now, before I exit this, the one last thing I want to show you is that there was a thing where we discussed that we could change the number of registers, and that works for shift around as well. If I simply move this here, add another JK flip-flop here, do the exact same thing where the output of this becomes the input of this, the output of this becomes the input of this, and the output of this becomes this one that shifts around. Basically, it's only changing the fact that the last one is now the fifth one instead of the fourth one. And this also goes to shift around, going all the way there. And finally, the shift pulse connecting to all of them as it did before. Connecting to the fifth one as well. And it should work exactly the same. For example, if I want to shift this value around, 1, 0, 1, 0, 1, it should work the same. After 4 clicks, 1, 0, 1, 0, 1. That's exactly what we get. So it still works for the same thing. And you can do this by removing a register too, as I showed you in the shift left and the shift right register. And finally, that's how all the shift registers work. Okay, so before I end the video, I would like to mention the one last thing that you should know about shift registers is that there are two types, synchronous and asynchronous. And the main difference between them is with synchronous shift registers, the clock pulse, that is this, or in this case, the button, it's a different clock pulse used for each and every one. That is, this, not different, but as in every one gets their own clock pulse. As in this one gets its own, this one gets its own, this one gets its own. Same here. Each and every flip-flop gets its own clock pulse. Yes, it's the same one, but they each get their own. That's what makes a synchronous shift register. In asynchronous shift registers, what would happen there is the output of this would be the clock pulse of this one. The output of this will be clock pulse of this one. The output of this would be the clock pulse of this one. So only the first one would have an actual clock pulse. The rest would simply share the output of the previous ones as a clock pulse. So basically meaning they all work on one clock pulse. Whereas in synchronous ones, as we can see, each of them have their own clock pulse. And that's the main difference between asynchronous and synchronous shift registers. Thank you.